Hi, and this is section 8.2, and it's called exponent properties with quotients. Now, if you think back to the last video we watched, it was exponent properties involving products. So we are working on exponent properties where we are multiplying things. Today we're going to be working with exponent properties with quotients. So a couple things to quickly review, and right now I should mention this. We'll start on page 495 today. All right, if you need to pause the video and go there, do that. A couple things to review. Remember, the word exponent, we all know what an exponent is that it's that raised number with a base, like I'll just make up something, a to the 5th power. The exponent here is 5. And now remember, what is a quotient? You know, quotient is just a fancy word that means we're talking about a division. It's the result we get as a result of dividing. So today we're working with exponent properties that deal with division. There's two properties we have to learn. One's on page 495. It's in the blue box in the middle of the page, the quotient of powers property. And then the second property we're going to learn is on page 496. If you turn the page real quick and you look at that, it's called a power of a quotient property. So we'll look at both those and learn it. So we're going to use exponents. This section's over using exponents in relation to dividing. And it's just like the previous section. Our goal is to be able to do these without showing work. It's kind of like your times tables. This should be quick mental math. Just like the last section. We didn't have any hard mental math. It was quick mental math. Didn't have a lot of work to show. We just had to understand three basic properties of multiplying with exponents. Today, we have two basic properties to learn. I want to set this up like I did on my last video. Remember on my last video I had these worksheets made out. I don't have worksheets made out for this video, so I kind of handmade my own, and so I'm just going to quickly draw these in to kind of make a little worksheet for us. Alright, so I got a few problems. We're going to do the exact same thing we did to start the video yesterday. I'm actually going to show you what's going on in each of these, and at the end we can get a little rule for it. Alright? So let's take a look at each one of these questions. The first one is we have an expression a to the 8th divided by a to the 3rd. Now when I expand that out, a to the 8th means 8 factors of 8. I'm sorry, 8 factors of a, I meant to say, I misspoke. And then I have 3 factors of a in the denominator. Now if you think about that, 3 factors of a in the denominator will cancel with 3 factors of a in the numerator. And I'm left with 5 factors of a. I'm left with a to the 5th power. Let's look at this next one. I have 10 factors of x in the numerator. So I'm getting 10 factors written down. And I have 7 factors of x in the denominator. Okay, 7 factors of x in the denominator. Well, you might immediately notice I can cancel 1 of each in the numerator with 1 of each in the denominator. If I cancel 7 in the denominator, I can cancel 7 factors of x in the numerator. I am left with 3 factors of x. I'm left with x to the 3rd power. And finally, in this one, I have 5 factors of b times 2 more factors of b, and I'm dividing that by 6 factors of b. Well, 6 factors of b in the denominator will cancel 6 factors of b in the numerator, and I'm left with, well, b to the 1st power. I can just write b for that. I think by doing these 3, some of you have probably already found a quick mental shortcut to doing each of these. It's as simple as subtracting the exponents. So do you notice here, if I just did 8, when I'm dividing with the same base, I can just subtract the exponents. 8 minus 3 was 5. I have the same base, x here, 10 minus 7 is 3. And I have the same bases here. Now remember, this would be the equivalent of b to the 7th. Remember yesterday? we had a property, if you want to turn back, it was on page number, I'm going back myself, 489. The first property we learned yesterday was the product of powers. If you have the same base, remember, we can just add the exponents. So b to the 7th over b to the 6th, that's the division. I have the same bases, I can subtract these, I get b. So that would be the rule. When dividing with the same bases, okay, when dividing with the same bases, just subtract the exponents. Okay? And I'm sure, I haven't actually looked and saw what they put in the book, but that's basically what they have said on page number, I got to get back to it, page number 495. When to divide powers having the same base, subtract the exponents is what they put in the book. So I hope this is a good visual of what this rule is telling you. Okay? Let's go on to the second rule we need to learn today. And the second rule is called the power of a quotient. And by the way, I should add that on here. This rule is called the quotient of powers property. That would be good to remember for your notes. I probably will ask tomorrow, what are the names of the two properties on your audit? Okay, so the first property is the quotient of powers property. All right, so the second property we need to learn then, let me set up a little table here, same kind of idea. I want to set up a table. We're going to learn what the power of a quotient property is. Okay, so I'm just going to set this up here. All right, so let's do each one of these. I'll get this out of the way. Okay, so first of all, I have 2a cubed over b squared all cubed. Now this means I have three factors of this fraction. So this would mean that I have 2a cubed times 2a cubed times 2a cubed on top. And I have b squared times b squared times b squared on the bottom. Can you see I have three factors? I have three factors here, and I have three factors here. And the reason I say three factors is because we have the third power. Okay? Now, let me simplify this expression up here and rearrange. Since I'm multiplying all these together, I have 2 times 2 times 2. I have the three factors of 2. But I also have the a cubed, a cubed, a cubed. And in the denominator, I have b squared, b squared, b squared. Just I'll write those again. Okay, now I can use some of the properties I learned yesterday. Remember, our first property again, I'm just turning back to, thinking about the last video. I'm going back to page 49, the product of powers property. Remember, if I have the same base, and I'm multiplying, I can just add the exponents. So does this make sense? 2 times 2 times 2 is 8. And a to the third times a to the third times a to the third, since the bases are the same, I can add these exponents. That's a to the 9th. And in the denominator, since I have the same bases, I can add the exponents. That's b to the 6th. And since these bases are not the same, I can't divide. There's my simplified expression. 8 times 8 times a to the 9th over b to the 6th. Let's try this one. I have negative 5 over 7x to the second power. Well, that means I have negative 5 times negative 5 in the numerator, two factors, right? I got two factors here. And I have 7x times 7x in the denominator. Well, negative 5 times negative 5, that's easy, that's 25. Now remember here, 7x means 7 times x. So I have 7 times x times 7 times x. Well, that's, I'm just thinking in my head, that's 49x squared. That would be my simplified, I guess I could have wrote it over here. That would be my simplified expression. And then finally here I have three factors of 3a to the 4th that I got to multiply together. And I have three factors of 5b that I have to multiply together. All right, so in the numerator I have 3 times 3 times 3, but I also have a to the 4th times a to the 4th times a to the 4th. And in the denominator I have 5 times 5 times 5, but I also have b times b times b. Well, again, I'm using the power of products property. If I have the same base, I can add the exponents. So I know I have an a to the 12th in the numerator. 3 times 3 times 3 is 27 in the numerator. 5 times 5 times 5 is 125 in the denominator. And b to the 1st times b to the 1st times b to the 1st. Remember, add the exponents. That's b to the 3rd. Okay, there's my simplified expression. So my rule is when I'm taking a fraction to an exponent, like I am in each of these examples, apply that exponent to both the numerator and the denominator. Okay? So remember, numerator, if I'm speaking a foreign language here, numerator is apply this power to the top of the fraction, and denominator, that means apply the power also to the bottom of the fraction. So those are the two rules that we have to understand with division. Okay? If we're dividing with a quotient, oh, I misspoke. I just used the same word twice. When I'm dividing with powers, when I have a power of quotients, okay, product of powers, or a product of quotients, I should say, I should be subtracting the exponents. In this case, if I have a fraction to a power, or they call this power of a quotient, then I should be applying that power to each numerator and denominator. So we have a quotient of powers. This is a quotient, a division of powers here. And here is a power of a quotient. Okay? We'll do a couple problems together here just to see a few in action. Let's take a look at things like, well, here's some simple things. If you look at number 3, it's simply 5 to the 6th over 5 squared. And all they're asking you in the directions is to simplify, write your answer with exponents. So in other words, we don't have to figure out, what that actual base to power is. They just want us to write the answer with an exponent. So here, this would be the quotient of powers. I have the same base, 5. All I need to do is subtract these exponents. I get 5 to the 4th power. Very simple. Okay? A question like 9. I have 10 to the 5th times 10 to the 5th over 10 to the 4th. Well, remember here I have a product of powers. Add the exponents. I have 10 to the 10th in the numerator. I have 10 to the 4th in the denominator. Here is a quotient of powers, so remember, subtract. I have 10 to the 6th. Sometimes people look at these and they think these are tricky, like in 15, it's 7 to the 9th times 1 over 7 squared. Okay, now remember, 7 to the 9th is like having 7 to the 9th over 1. So you really have 7 to the 9th over 7 squared. Okay, very simple. You have a quotient of powers. Just since the bases are the same, subtract the exponents. You get 7 to the 7th power. Okay. Looking ahead, when you look in the bookwork and you go to a problem like number 33, this is a little bit tougher. But it's just using the rules that we've learned today. You have 3x to the 3rd power over 2y, and that is all squared. And we're multiplying that by 1 over x squared. Okay, so first of all, we have to apply the power of quotient property. So the second power means that for here, I have 3x to the 3rd times 3x to the 3rd over 2y times 2y. And by the way, what I'm writing down here I would normally do this in my head. I would love it if you can do this in your head. I'm just writing it out so you can see what I'm thinking about in my head, okay? So can you see here, I'm really having 3 times 3 times x cubed, and then I have a times 1. And down here I really have a 2 times y times x squared. Well, I have 9. Since I have a product of powers, remember, add the exponents. I have 9x to the 6th. The times 1 isn't going to change anything. And down here, 2 times 2 is 4. I have x squared, and y times y is y squared. And now I have one more thing yet. Do you notice how I have x to the 6th in the numerator and x squared in the denominator? These are the same base. If you have the same base, remember, the quotient of powers, I can subtract these. I get 9x to the 4th over 4y squared. So again, I have a cancellation. 2 factors of x down here would cancel 2 of the 3 here. Can you see how I have 4 factors left? So I did a few examples of those. Just wanted you to see them. Obviously, if there's more questions, we can go over more. The one other thing I wanted just to quickly review, remember we talked about order of magnitude on the last video. I just wanted to review that with you real quick. Remember, order of magnitude is just simply, it means that you're rounding a number to the closest base 10 number to make an estimate. Base 10 number, remember, is exactly what it means, base 10. So it means 10 to an exponent. So base 10 numbers, I put this on my last video, could include 10 to the first, which is 10, 10 squared, which is 100, 10 to the third, 1,000, 10 to the fourth is 10,000, and so on, okay? With that said, remember, because they'll ask you about order of magnitude in this problem, in these problems today, what is the order of magnitude of this number? Again, I'm asking what base 10 number is closest to that? Well, the closest base 10 number, in this case, would be 10 to the 4th, because this is closest to 10,000, okay? So I did a few examples here. I showed you the 2 properties. If we need more help or questions when we get to this tomorrow, we can obviously go through more in class together. All right? I'm going to stop my video here.